Hello everyone. So what I've got is a system x of t to y of t, which equals x of t times cosine of omega t. So what we want to determine about this particular system is whether it is A, linear, B, causal, C, time invariant, and D, stable. So what I'm going to start with is whether it is linear or not. So A, linear. So we want to start off by saying that x of t is equal to alpha 1 x of t plus alpha 2 x of t. So this would give us our y of t. Our y of t would equal this particular x of t. So alpha 1 x1 of t plus alpha 2 x2 of t times our cosine of omega t. And so when we distribute this cosine to each one of these, we get that y of t equals alpha 1 x1 of t times cosine of omega t plus alpha 2 x2 of t times cosine of omega t, which we can further simplify as to saying that this is alpha 1 y1 of t plus alpha 2 y2 of t. So we have therefore determined that this is linear. So now what we want to determine is whether our system is causal. So, in order to do that, we could basically solve. For example, we could set our y of t at t equals 5. And so, therefore, we would have y of 5 is equal to x of 5 times cosine of 5 omega. And so we can see here that y of t does not depend on any of the future values of x of t. So these are all currently present values. And so therefore we determine that it is in fact causal. So next what we want to determine is whether it is time invariant. So we basically assign an x of t minus t0. And so after the system, x of t minus t0 would actually end up being x of t minus t0 times cosine of omega t. And so knowing this now, our y of t minus t0 would go to x of t minus t0 times cosine of omega times t minus t0. And so this y of t minus t0 and x of t minus t0 are in fact not one and the same. So this is not time invariant. And so what we've got for the last one, and I'm going to hurry because we're running out of time here. We want to determine whether it's stable. So we know that cosine of omega t is always going to be less than or equal to 1. So we can take the absolute value of y of t is equal to x of t times cosine of omega t. And that's always going to be less than or equal to the absolute value of x of t. So x of t is actually bounded, and y of t is also bounded. So this is in fact stable.